Hello everyone, I am Safir and let me welcome you on behalf of Focal Point Learning to our channel. So in this particular channel, what we are going to do is that we are going to provide guidance, we are going to provide updates and insights on a lot of different things, which are going to be relevant for various examinations that are actually, you can say, conducted at various levels, be it placement level examinations at your college. Okay, for that matter, any of the competitive examinations with respect to the government, banking. So you'll find something or the other which will be useful. So, what we are doing right now is that we are beginning a series on some of the interesting questions that have been asked in various of the examinations conducted by UPSC in the past year. Okay, so when you talk about UPSC, Union Public Service Commission, so when you talk about this particular body, so this body conducts various examinations. You might be knowing them depending upon what exactly is your interest. You might be knowing about Combined Defense Services (CDS). You might be knowing about engineering services examination, which is for the Indian engineering services, especially the four branches of engineering which are considered to be core. Okay, which is civil, mechanical, electrical, and triple E, that is electrical and electronics, or ECE. Then you basically have the other examination, like you have got the Central Armed Police Forces (CAPF). Okay, one of the most coveted examinations of India as well as the world, that is the Civil Services Examination and the Indian Forest Service Examination. Okay, so these are certain of the examinations which are considered to be public examinations which are conducted by UPSC. And in this particular session and in the coming series, we will be exploring some of the questions that have been asked from the concept of mental ability, for that matter, quantitative ability, and for the rest of the subjects, we basically mean that it is the numerical ability that we are going to see in this particular series. So this is the first of the lectures of this particular series, and we hope to serve more of you, help more of you get through these examinations. And subsequently, if you like this video, please subscribe our channel, like the video, share it amongst your peers, and I promise we'll be bringing in more useful content for you in simpler format and in simpler language, so that we are able to get through the biggest of the hurdles of the examinations. So right now we are taking up the questions which have come up in either of these examinations with respect to civil services and Indian Forest Services examination. We will be dealing with them at level 2. Why? Because first of all, we need to know what is there here. Okay, these are the fundamental questions. So, and most of the questions are the one which have a very similar pattern of repeating themselves in civil services examinations and forest services examinations. So once we build the fundamentals around these questions, which are really, really interesting, we are going to solve the civil services and forest services previous year questions as well. So let us begin this particular session with number system. So when you talk about this particular topic, number system, it is one of the most, you can say, extensively asked, frequently asked topic of any kind of examination that has an aptitude section. Okay, so when we talk about the number section, here we basically have the concept of numbers first of all. Okay, so the concept of numbers basically talks about the natural numbers, whole numbers. Then we may be talking about the prime numbers. Okay, then we have rational and irrational numbers. Okay, then you might be knowing about something called integers. Okay, you might be knowing something about real numbers. You might be knowing something about imaginary numbers as well. Okay, so these are basically all the kinds of numbers that we basically need to know just by the definition. Okay, what exactly is the definition of various numbers? Okay, how exactly are they expressed? How exactly are they seen? That is what we need to know. That is the first fundamental of this particular topic. And many a times the questions actually begin based upon these. Just like you may be having a question that we are considering to have only prime numbers to be considered in the question. You'll be seeing one particular question. Sometimes you might be asked that there are integers that you need to consider. Sometimes you would say that the values or variables that have been given in the question actually are only to be taken from the natural number. So unless you know the definitions, it will become difficult for you to answer such questions or take the assumptions. So these are basically the first hint in any of the number system questions to identify what exactly is the kind of number that you will be working with. Okay. Now building upon these concepts, then we have something called factors. Okay. And in factors, we basically go with divisibility. When one number basically divides other number and the remainder is zero, it is considered to be a factor. So there is something called the concept of divisibility rules. There is something which is called basically the concept of HCF and LCM. Okay, very, very important topics when you talk about it. Okay, third, we basically talk about the concept of remainders. Okay. So when we talk about the concept of remainders, now the point is that we are interested in finding out what would be remaining after a division operation has taken place. So remainders have got certain theorems, okay, that we need to understand. Then apart from this, the number system also covers the concept of exponents. Okay. So when you talk about the concept of exponents here, basically you have the unit digit. Okay, the concept of unit digit. You might be talking about the concept of laws of exponents. So these are basically the things that we actually talk about in this particular chapter. So when you cover number series in its entirety, so you can assume that you are covering approximately 30% of the entire quantitative aptitude syllabus. Okay, so that is basically the importance of number series. Okay. And when you talk about this particular number series, it is also going to form a significant part of any kind of paper that you're going to attempt. Okay. So how do you understand that you are actually ready to attempt a question on your own, or you are done with a particular topic? Whenever you see an unknown question, whenever you see a new question in front of you, and if you are able to pinpoint exactly what exactly is the concept involved here, from which chapter this particular question has come, that day you can say that, okay, I am through with this particular concept, and you would most probably be able to solve that question. Okay. So that is where we want to take you. But in order to get there, you will have to work upon yourself and subsequently use our guidance as your own, you can say, guiding lamp. Okay. So that is what we are trying to do here. So once we are done with this, let us now start very gradually with some questions that have turned up in 2024. Okay, with respect to some of the UPSC examinations. And subsequently, when we are done with this, you will be done with some of the concepts. So this is basically a refresher of some of the concepts that are involved in the number system. Okay, so let us begin this particular session, and let us go towards first question that was asked in the Indian Engineering Services Examination 2024. So the question is, Anuhya picks a number, she doubles the number, squares the result, divides the square by 3, subtracts 30 from the quotient and gets 18. What are the possible numbers that Anuhya could have picked? So basically here what has been given, that there is a number that has been chosen by a particular girl named Anuhya. Okay, so she picks a number. You don't know anything about this particular number. So it could be any number. So when you do not have a fixed quantity or fixed value, this is basically the question, or you can say this is basically the point where you use the concept of variables. Okay, so this particular number could be anything. She could be having any favorite number. She could be having any lucky number that she might be picking. So that is why what we do is that in order to find this particular number, we need to introduce something which is called a variable. A variable is basically a quantity that can have any, you can say that does not have any fixed quantity attached to it. It takes the, you can say it takes the quantity, whatever is given to it. So let this particular variable be X. Okay, so X basically denotes the number chosen by Anuhya. Okay. So X can take any value, whatever is assigned to it. So that is where we begin this particular question. So that is the first step that we need to decode. The second thing, now we are going to follow the steps that she has followed. Now the first step that she has done is that she has chosen a number. We have also chosen a number. She doubles this number. Okay. So step two is doubling. So when we double this particular number, it becomes 2x. Okay. Third step, what she does, she squares the result. So now she is squaring this doubled result. Okay. So when you square this, it basically becomes 2x whole square, which is 4x square. Okay. Then the fourth step she is doing is that she is dividing this particular result by 3. So dividing by 3. So that basically becomes 4x square by 3. Okay. And then what is written finally, that she subtracts 30 from the quotient. So when you talk about this particular statement, there is a very, very important word which is written here, that whatever is the quotient here, okay, of 4x square divided by 3, she is going to subtract 30 from it. Okay. So I'm going to come back to this, why I have underlined it. But as of now, just see this, that it will be 4x divided by 3 minus 30, which gives us the result of 18. And this is basically where the operation stops. So now we are supposed to be finding this particular number. So we see that this particular equation is the one which is basically an equation in one variable. So what do we know about this equation? This equation has one variable, okay? And then at the same time, this equation is quadratic, okay? Equation is quadratic. And why do we say that this is a quadratic equation? Because the variable has got a power of 2, and that is the highest power of the variable. Okay, so that is something which is also called degree of an equation. So the degree of this equation would be 2. Okay, so now we just have to solve this particular question. Okay, it's a very, you can say, straightforward thing that we need to do. So let us now solve this particular question. So now we have to just go with this. So what we are going to do, 4x square by 3. If I take 30 to the right hand side, the sign will change. So it will become 30 plus 18. So that will basically become 4x square by 3 is equals to 48. Now I want to find the value of x square. So what I'm going to do, I'm keeping x square here and I'm transporting everything else or transposing everything else to the other side. Okay. So that will then become 48 multiplied by 3 by 4. Okay. Why? Because with respect to x, whatever was in multiplication, that will go in the division, and whatever was in the division will go in the multiplication when we are cross multiplying it. Okay. So from here we basically see that 4 times of 12 is 48. So we get x square equal to 36. So this is the square of x. So when x is multiplied with itself 2 times, we get 36. Okay. So what we have to find out is basically something which is called the square root. Okay. So when you go to the square root, so that is basically root over of 36. Okay. But the point is that we understand that when we multiply a positive number with itself, it gives a positive quantity. But at the same time, if we multiply a negative number with itself, it will also give you a positive quantity. So basically what I'm trying to say, if there is a number a and I multiply it with a itself, I will be getting a square. That is true. Okay. But if there is a number minus b and I multiply it with itself, that will also give me a positive quantity. So that is why 36 x square is equals to 36 can either be formed by multiplying a positive number with itself or by multiplying a negative number with itself. So that is why whenever we find this particular root, we also add this particular sign, which is called a plus and a minus. So this basically tells us that there could be two values that x could take. And these two values then would be either a positive value of 6 or negative value of 6, because we know that 6 squared is going to give us 36. So going by this particular principle, what we are trying to say is that 6 into 6 is going to give you 36. At the same time, minus 6 into minus 6 will also give you 36. Okay, so in both the cases, we have this particular situation that the ultimate result would be 36. Okay, and at the same time, what we also get to learn from this equation or this problem is that the answer, apart from the answer, which is plus 6 or minus 6, what we also find out is that solving a quadratic equation. Okay, this is basically the solution of a quadratic equation will give us two values of x. Two values of x, okay, which is also called the root of the equation. Okay, so I hope this is something which is clear. So because x had the you can say power of 2, so that is why here we will be getting two different values of x. So one of them is plus 6 and the other one is minus 6. So this is a principle that is going to be valid for all quadratic equations. Okay, that you will be getting two roots. Now the nature of these roots could be different, that we'll be discussing at a later point. So the answer to this question would be plus 6 or minus 6. Now I had already underlined this particular word which is called quotient. Okay, and why am I doing this? Because in this particular question, this is the assumption that you have to take, that when you are trying to subtract 30 from the quotient of the result, so that is something which will be a definite value. Okay, so basically what happens is that there are two things when we divide, when we do the operation of division. Okay, so whenever we are doing the operation of division, just a moment. Yeah. So whenever we divide, so upon dividing, what happens is that let us say that there is a number capital D that is being divided by a small number d. Okay. So there will be some kind of quotient. There will be some value here, and then there will be a value here. Okay. So this is the divisor. This is the quotient. Okay. And this is the remainder that we know. And this is basically the dividend, the number that is to be divided. So whenever we write this particular thing in a shorter manner, so what we write it as, this operation is basically written as capital D divided by small d, and the result that we get is basically called the quotient. Okay. But at the same time, sometimes it also happens that when we are trying to divide this particular operation, so we see that there is some remainder as well. Okay, so that is something which may be represented as d mod d. Okay, so whenever we have this particular word mod, this is basically called modulus. And modulus basically means you have to consider the remainder of the operation. Okay, so there are two things. In a division operation, we basically get a quotient and we basically get a remainder. So when we are considering the quotient, so this is the symbol that we use. And sometimes you might be finding this particular word mod, you might be finding this particular word remainder, okay, or you might be finding this particular symbol, d mod d. Okay, so in all these three, you basically try to find out what you're talking about is basically what would be the remainder of this particular operation. So remember this. This question says that you have to talk about the quotient, not the remainder. So that is why you were basically using 4x square divided by 3 minus 30. Okay, so this is something that I wanted to point out here. Now let us go to the next question that we have. So I hope this question makes sense to you. Now let us go to the next question. So this question was asked in CDS 2024, and the question was, what is the sum of the largest and smallest four-digit numbers made using single-digit prime numbers? Okay, so what has been given to you? Sum of largest and smallest four-digit number. So you have to find the sum of a four-digit number made by single-digit prime number. So now you might be understanding what I was trying to tell you, that the question itself is going to say what is the kind of numbers that you're going to work with. So this question says that you're going to work with prime numbers and at the same time you're not repeating any of them. Okay, so in a particular four-digit number, none of the digits are going to be repeated, and what we are going to find out is basically the prime numbers. Okay, so when we talk about the concept of primes, when we talk about the concept of primes, so prime number is basically a number which has only two factors. Okay, it has only two factors, and these factors are 1 and number itself. Okay, two factors, 1 and number itself. So basically what happens in this particular case is that when we talk about the prime numbers, so the definition is that there should only and only be two factors. If there are more than two factors of a particular number, okay, so if a number has more than two factors, so in that particular case, what is going to happen, that this is something which is going to be called a composite number. Okay, it is called a composite number. Okay, then subsequently what happens is that all the other numbers, just like you might be knowing about the number, let us take an example of 12. So when you talk about the example of 12, so this particular number can be written as 2 times of 6. It can be written as 4 times of 3. It can be written as 12 times of 1. Also at the same time, it can be written as 6 times of 2, 3 times of 4, 1 times of 12. So basically when we talk about the number 12, so it has got 2 as its factor, 6 as its factor, 4 as its factor, 3 and 1. So it has more than two factors. So such a number is basically called a composite number. Okay. Now talking about the concept of, you can say 1. So when we talk about the number 1, okay. So when we talk about this particular number, so this number is neither prime. It is neither prime nor composite. Okay, now basically what happens is that when we talk about this number 1, so why exactly is it not a prime? So 1 is a factor of all the numbers. Okay, so 1 is a factor of all the numbers. But at the same time, when you talk about this particular number 1, it has no other factor except for 1 itself. So when you talk about the concept of prime numbers, you need two factors. Okay, and one of them is already 1. The other one should be number itself. So here 1 and number itself is the same. So technically you have only one factor. And that is why it is not a prime number. And because it has only one factor, so it also does not fit in the concept of composite numbers. And that is why when you talk about 1, it is neither prime nor composite. So that is why the prime numbers basically start from 2. Okay. So 2, 3, 5, 7, 11, 13, 17, 19, and so on are basically the prime numbers that we know. Okay. And now when you talk about this particular number 2, this is the only even prime number. There is no other prime number which is even. Okay. And at the same time, there is no other factor of 2 except for 2 itself. So 2 and 1 are the only factors of 2. That is why it is a prime number. Okay. Apart from that, all the other even numbers are the one which are actually having a factor 2. So they are not a prime number. Now the next thing, this particular question says that we have to make 4-digit numbers. We have to make 4-digit numbers without repetition. So when we are actually making a 4-digit number, it should not have any of the digit repeated. The next thing that has been told to us is that we need to follow a very strict set of numbers, that is single digit prime numbers. So when we talk about the single digit prime numbers, so we have only four such numbers. We have only four single digit primes, 2, 3, 5 and 7, and that is the whole reason why it is basically telling you to go for a 4-digit number. Because if there is a fifth digit that is added up, or if there is a third digit, if we have to go for a 3-digit number, or we have to go for a fifth digit as well, so there might be a chance that there could be any kind of repetition. Just like when you go for a fifth 5-digit number, there will be a repetition. Okay, but when we talk about this particular problem, 4-digit numbers, it will not have any repetition. So we basically have to choose amongst these 4 digits. Okay, now these 4 digits, we have to find out the largest and the smallest. If we have to find out the largest of the number, so we have to, you can say, place the numbers in such a way that the highest place values are the one which are with the largest of the digits. These are the highest place values. Okay. And this is the lowest place value, that is basically units digit. So technically, how do we actually have to place the numbers? The bigger the number, the bigger the real value of the number, the higher the place. That is how we are going to get the largest number. Okay. So that is why, how exactly are we going to arrange it? The largest of the four primes is 7. Then the second largest is 5. Subsequently, then it is 3 and then 2. So this is basically the largest 4-digit prime numbers. Okay. Largest 4-digit prime without repetition. Okay, this is without repetition. And subsequently, if we want to go for the smallest 4-digit number, which is made exclusively of the primes. So in this particular scenario, what we will have to do, we will have to give the highest place value to the smallest of the numbers. So subsequently, the smallest is 2. Then subsequently, there will be 3, then 5, then 7. And what you are supposed to be doing, you have to add them two together. So when you add them two together, so you basically get 7 plus 2, 9. This is 8, this is 8, and again, this is 9. So this is basically the number that we are looking for. So the number is 9889. Now, when you go about this particular number, let me also give you another interesting fact that all these four numbers which are here, they are all divisible by 11. Okay, they are all divisible by 11. And how exactly do we see that? We have 4 digits. Okay, so let these are the odd places and these are the even places. Okay, so let us say these are the odd places, these are the even places. So in all such, you can say numbers, you basically see when you add the odd places together and you add the even places together and you take the difference of the two, you get the difference as 0. Okay, so in the first one, you basically have 7 plus 8. That is the two odd places. Then we have the other two even places, that is 8 plus 7. And when you take the difference between the two, which is basically the divisibility criteria of 11, that gives you 0. So when you have to talk about the divisibility criteria of 11, always remember that you have to take the sum of the alternate places. Okay. starting from the rightmost digit, you have to start taking the sum of the alternate digits. And after taking the sum of the alternate digits, take the difference between the two sides. Okay. The sum of the two, you can say two alternate digits, you basically have to take the difference. If the difference is either 0 or 11, divisible by 11, in that particular case, the number is divisible by 11. Okay. So this is basically the divisibility rule. You can be applying it to anyone. Just like here you have 9 plus 8, 17. 8 plus 9, 17. 17 minus 17 is 0. So this basically tells you that this number is also divisible by 11. So what we get to know, even though the 4-digit numbers that we have made, 7532 and 2357, they are made exclusively of the primes. But we basically see here that the number which is found out of their sum is something which is divisible by 11. So that is not a prime. Even 7532 is not a prime. Okay. So that is something that we keep on realizing. So I hope this question is clear. Now let's go to the next one. What is the value of x where x is 0 less than equal to x less than equal to 8 if 100 to the power 97 plus 100 to the power 54 is plus x plus 1 leaves a remainder of 0 when divided by 9. Okay, so this question is basically dependent upon the divisibility. And when we talk about the concept of divisibility, so a number is divisible by another number. So in this particular case, the divisibility of this particular number is to be checked with that of 9. So in order for this number to be divisible by 9, the remainder of the operation should be 0. Okay. So that is why in this particular question, what we have to do, we have to check for the remainders. Okay. So we have to check for the remainders. This is something that we have to do. Now, how do we do that? Okay. So the question that has been given is 100 to the power 97 plus 100 to the power 54 plus x plus 1 needs to be divided by 9. Okay. So subsequently, what we are going to do, we are going to individually consider the remainders of these, you can say various numbers that we have. So we basically want to consider the remainders of 100 to the power 97 divided by 9, 100 to the power 54 divided by 9, 1 divided by 9, and 1 divided by 9 and x divided by 9. Okay. So we can right now figure this out that x divided by 9 will not be getting any kind of value as of now because we don't know what is x. Okay. Rest of the others we can compute the remainders. How do we do that? Okay. So let us attempt this question now. We know that 100 is basically 10 squared. When we multiply 10 with itself, so that we get 100. So subsequently, 100 can be written as 10 squared. So we have 100 to the power 97. Can this be written as 10 squared to the power 97? Okay. And subsequently, can this be written as 10 to the power 2 into 97? This is basically coming from the laws of exponent. X to the power a to the power b is equals to x to the power a into b. Okay. So this basically then becomes 10 to the power 194. Okay. Similarly, we can be writing 100 to the power 54 as 10 squared to the power 54, which can be written as 10 to the power 2 into 54, which again can be written as 10 to the power 108. Now, why exactly are we doing this? Okay, because we have a very important conclusion here. We know that remainder of 10 divided by 9 is 1. We can divide this. If we divide 10 by 9, so 9 times of 1 is 9 and we have 1 as remainder. Okay. So basically what is going to happen is that whenever we are going to divide 10 by 9, we are always going to get the remainder 1. Okay. So if we basically divide 10 to the power 194 by 9. Okay. If we want to consider the remainder of 10 to the power 194 by 9, So this will basically be 1 to the power 194. And why is this happening? Just imagine I have 10 chocolates. Okay, I have 10 chocolates and I want to distribute it to 9 students. Okay, so if I want to distribute it to 9 students, so after distributing 9 chocolates, I will be left with 1 chocolate. Okay. Similarly, if I basically have 100 chocolates, so if I have to distribute these 100 chocolates to 9 students equally, so in that particular scenario, I will be giving each of them 9 chocolates each. Okay. So after giving 9 chocolates to them, then subsequently I will still be having, when I have 9 students, I will be giving them 11 chocolates each. After giving 11 chocolates each, I will still be having 1 chocolate. Similarly, if I have 1000 chocolates and I have only 9 students, so every time I am going to divide any number of chocolates into students. So what exactly am I going to get? I will always be having the remainder as 1. I will always have 1 chocolate remaining with me. No matter how large the number of chocolates I am dividing and what is the size of portion every particular person is getting. So subsequently, if I divide 10 to the power 194 by 9, so my remainder will also be 1 to the power 194. Okay. And we know that 1 to the power n, where n is any integer, will always be 1. Okay. So it will give me the remainder as 1. Okay. Subsequently, also the remainder of 10 to the power 108 divided by 9. This will be basically 1 to the power 108, which will again be 1. At the same time, the remainder of 1 divided by 9. So when I divide 1 by 9, the remainder will again be 1. Why? Because if I divide 1 by 9, so 9 times of 0 is 0 and the remainder is 1 again. So what I find is that the remainders of 10 to the power 97, 10 to the power 54 and 1 by 9, all of them are basically 1. Okay. Now the only remainder that needs to be checked is basically the value of x. Okay. And if the value of x is somehow placed in such a manner that it is divisible by 9, the entire number would be divisible by 9. So how do we do this? Now we know that the number is given in this particular form: 100 to the power 97 plus 100 to the power 54 plus x plus 1. So similarly, the remainders will also be added in the same manner. Okay. So when the remainders are going to be added, so the effective remainder that actually comes from this particular concept is that of 1, that is 10 to the power 10 to the power 194th remainder, that is 1. Then 10 to the power 108, again the remainder is 1. The remainder of 1 divided by 9 is 1, and we keep x as it is. Okay. So the remainder that we basically get is 3 plus x. Now, in order for this particular remainder to be divisible by 9, it should be at least 9. Okay. The sum should actually be 9. Only then we will be having this particular number to be completely divisible by 9, because then if we divide 9 with itself, so that is 9 times of 1. So the remainder will be 0, and that is what we require. Okay. So subsequently, in this particular case, what we have to do, we have to equate 3 plus x is equals to 9. So from this particular equation, we get x is equals to 9 minus 3, that will be 6. Now, when we get this particular value, x is equals to 6. Now, this is something which also satisfies the condition that it is lying between 0 and 8. Okay. So when x is 6, so the remainder of 6 divided by 9 will again be 6. Okay. So 1, 1, 1 and 6. So 6 plus 3 gives you 9, and 9 divided by 9 would be, the remainder would be 0, and this entire number for the value of x will be divisible by 9. Okay. So the correct answer to this question would be that the value of x should be 6. Okay. I hope this question is clear to you. So this question basically is from the concept of divisibility and remainders. Okay. Now let's move to the next question. Now this particular question says, a 4-digit number n has exactly 15 distinct divisors. What is the total number of distinct divisors of n square? So this particular question is a straight application of something what we call as the fundamental theorem of arithmetic. So there is something called the fundamental theorem of arithmetic. Okay. And what exactly does this particular theorem tell us? This particular theorem tells us that any natural number, any natural number greater than 1, or let us say greater than 2, okay, greater than 2 can be expressed as a product of primes, or for that matter, product of powers of primes, powers of prime numbers. Okay, so this is basically what is the fundamental theorem of arithmetic, and this is nothing but what we know as something called factorization. Okay, this is exactly what we know as factorization. So when we prime factorize a particular number, let us say we have a number, let us say the number is 48. Okay, so when we prime factorize, what do? We start dividing this number with the smallest of the prime factor, that is 2, because it is an even number. So when we divide this particular number by 2, the quotient is 24. That is what we write here. Okay, so now this is 24. Again dividing by 2, this becomes 12. Then dividing by 2, this becomes 6. Again dividing by 2, we have the next one. The quotient is 3. Now 3 is not divisible by 2. We go with the next higher prime, that is 3. And finally the remainder is 1. Okay. So now 48 is basically 2 into 2 into 2 into 2 into 3, which can also be written as 2 to the power 4 into 3 to the power 1. And here 2 and 3, both of them are prime numbers. This is basically why it is called prime factorization. And now 48 can be represented as a powers in terms of powers of prime, 2 raised to the power 4, 3 raised to the power 1. And that is basically how we get this particular number 48. This is exactly what this theorem says. So any particular number n can be expressed as a product of powers of primes. Okay, so it can be written as p1 to the power a into p2 to the power b into p3 to the power c, and so on. This is basically the mathematical expression of the fundamental theorem of arithmetic. Okay, where p1, p2, p3 are all primes. And when they are all primes, what we basically want to say is that all the divisors of n can be also represented in this particular format. Okay, just like when we go with this particular multiplication, we find that 48 can be written as 16 times of 3. It can also be written as 8 times of 6. It can also be written as 12 times of 4. So they basically are nothing but different groupings of these factors. Okay, and we get these divisors. So exactly this is something which we are going to find out now. Okay, so now when we understand this particular you can say concept, that how exactly a particular number greater than 2, or if we want to be very specific, let that be greater than 1. Okay, I'll just remove a few things from here. Yeah, so sorry. So when we talk about this particular number, so now if we want to find out the number of distinct divisors, so number of distinct divisors of n is basically given by the formula a plus 1 multiplied by b plus 1 multiplied by c plus 1, and so on. So whatever are the powers of p1 to the power a, p2 p2 to the power b, p3 to the power c, these powers are the ones with which you have to add 1 and multiply, take their product. Okay, that is basically the number of distinct divisors that a particular number can have. Okay, so subsequently what has been given in this particular question, that there are exactly 15 distinct divisors of n. So when we talk about this particular statement, 15 distinct divisors of n, so 15 can be written as 5 into 3. Okay, so what exactly are we going to do? We are going to basically find out we are going to use this particular relation as the above equation. Number of distinct divisors is 15. 15 can be broken down as 5 into 3, which can be further broken down as 4 plus 1 into 2 plus 1. This can be written. Okay. So now if we write it like this, so we exactly go with this particular formula, number of distinct divisors. Okay. So when we talk about the number of distinct divisors, so what exactly is n? Then n basically becomes p1 to the power 4 into p2 to the power 2. Okay. This is basically what it becomes, p1 to the power 4 into p2 to the power 2. Okay. And then subsequently, what exactly is the next thing that we are going to do? We have to find out what is the number of distinct divisors of n squared. So when we square n, so this will basically become p1 to the power 4 into p2 to the power p2 to the power 2 whole squared. Again, using the laws of exponents, it will become p1 to the power 8 into p2 to the power 4. So now what is A? A is 8, B is 4. So now if we have to get this particular formula, so number of distinct divisors. So number of distinct divisors will now be 8 plus 1, that is 9, and 4 plus 1, that is 5. That will become 45. So 45 would be the number of distinct divisors that n square is going to have. So the correct answer to this question would be 45. So this was a straight application of this particular property which is given here. The number of distinct divisor of a number n can be given by can be given if we basically express it in terms of prime numbers power. Okay. So we need not find the number itself. We just need to express it in this particular format. So that is what we did and we found out the answer. Okay. So again, this was a question which came up in CDS 2024. Okay. Now let's go to the next question. So now going to the next question. So this question is, what is the HCF of 2 to the power 36 minus 1 and 2 to the power 45 minus 1? Now this particular question can be solved using a property straight away. So write down that property. Okay, so whenever such a question is given, HCF of 2 to the power, let us say m minus 1 and HCF of 2 to the power n minus 1. Okay, if it is given in this particular format, so the HCF is basically given as, I will write it down here, 2 to the power HCF of m and n minus 1. Write down this particular formula. Okay. So basically the HCF of 2 to the power 36 minus 1 and 2 to the power 45 minus 1 would be 2 to the power 36 minus 1 and 2 to the power 45 minus 1 is basically 2 to the power HCF of 36 and 45 minus 1. Okay. So this is basically what is going to be the answer. So what we have to do, we simply have to find out the HCF of 36 and 45. Okay. So when we talk about 36, so 36 can be written as 4 times of 9, which can be written as 2 squared into 3 squared. Okay. When we talk about 45, 45 can be written as 5 times of 9, which can be written as 5 to the power 1 into 3 squared. So HCF is basically the factor which is common. Okay. And how many times it is common. So we find that there is only one factor which is common between the two, and that is 3 squared. And that is why the HCF would be 3 squared, that is 9. So subsequently, the HCF, that will be 2 to the power, HCF of 36 and 45 we found is 9 minus 1. Now, if we want to simplify this further, what we are going to do, we are going to write 2 to the power 9 as 2 to the power 3 into 3. Okay. Minus 1. And then we can be using the formula 2 to the power 3 to the power 3 minus 1. Okay. This is basically coming from the same result, x to the power m to the power n is equals to x to the power m into n. Okay, so 2 cubed is 8 and 8 cubed minus 1. So 8 cubed is 512. So 512 minus 1, that gives 511. Okay, so this is basically the final value. So the answer to this particular question would be 511. That would be the HCF of 2 to the power 36 minus 1 and 2 to the power 45 minus 1. Okay, so use this particular property and straight away get this result. So that was the question. Now, the last question for this particular session, and this basically came up in the lower division clerk examination for CISF in 2024. And this question is basically which one among the following digits can never be at the units place in the 273 to the power n, where n is a positive integer. Okay, so basically you have been given a particular number 273 to the power n. So 273 basically is the base and n is the exponent. Subsequently, we see that the base has a unit digit 3. It has a unit digit 3. Okay. Now, basically, this question is based upon the concept of unit digit. So the concept here is basically of units digit. Okay, unit digit. But in order to get this particular unit digit, we are going to find out something which is called cyclicity. Okay, we are going to find out cyclicity of the units digit of the base. Okay, that is what we are going to find out in this particular question. So this particular question has base 273. The units digit of the base is 3. Okay, so whatever is going to come in the units digit of the entire expression 273 to the power n, that will have the same units digit as the power of 3 to the power n. Okay, it will be the same thing. You can also do this the other way around if you want to check how exactly this comes up. So you can take up any big number. Okay, let us say you take up 12. Okay, so when you square 12 squared is 144 when you square 12. So what is 2 squared? It is 4. Isn't the units place same? Let us take 13. Okay, 13 squared is 169. Isn't 3 square equal to 9? At the same time, 14 and 14 squared is 196. Isn't 4 squared equal to 16? So the units place is same. So exactly this is the situation that we have to understand. Okay, that whatever is the units place of the larger quantity, that will have, if it is raised to certain power, it will give you the same units place. Okay, as that of the units place digit. So that is what we have to understand here. So if we understand this, now we are going to find out something called cyclicity of 3. So cyclicity is basically a concept where we understand that when we actually study the powers of various numbers, and what we are trying to study is the units place of this particular number, it eventually repeats itself. Okay. So when we study the power of 3 from 3 to the power 1, so 3 to the power 1 is 3, 3 squared is 9, 3 cubed is 27, 3 to the power 4 is 81, 3 to the power 5 is 343. Sorry, 243. 3 to the power 6 is 729. Okay, so what do we see? That the units place actually starts repeating itself after the fourth power. Okay, so 3 to the power 5 has the same units place as 3 to the power 1. 3 to the power 6 has the same units place as 3 to the power 2. Okay. Subsequently, when we are going to go for 3 to the power 7, so it will basically have the same units place as that of 3 to the power 3, which would be 7. So what we see from here is that cyclicity of 3 is 4. That after every 4 powers, after every 4 consecutive exponents, the fifth consecutive exponent is the one which will have the units digit of the first one. Okay, so 1, 2, 3 and 4. After 4, the fifth exponent is basically the one which has the same units place as the first one. Subsequently, when you start from 3 squared, so 3 to the power 6 has the same units place. So that is why this is something which is called cyclicity of the units place. So cyclicity of 3 is 4. But this question is even more simpler. What we need to understand, what are the units place? What digits can actually take the units place in the, you can say, powers of 3. So units place can be taken by 3, 9, 7 or 1. So out of these four options, there is only one option which can never be in the units place of 3 to the power any number, which is an integer, and that is 5. So subsequently, 273 to the power n can have any integer 3, can have any value, but the unit place will only be 3, 9, 7 or 1. It cannot be anything else. So that is what has been asked in this particular question. Which of them can never be the units place of 273 to the power n? So the answer to that would be 5. Okay. So this is all for this session. I hope this particular video helped you understand a few basic concepts, and at the same time this is something which also helped you understand how these questions need your approach to be. Okay? So clear understanding of concepts is something which is of paramount importance in solving any of the aptitude questions, and that is what we are trying to do here by helping you out. So if you like this video, please do comment so that we can understand how exactly do you want us to improve. And at the same time, please also share it amongst your peers so that they can also benefit from it. And definitely please subscribe. So until next time, thank you so much. See you in the next video with a new concept. Thank you.